So let's get going and actually create our partitioned objects for testing. First up, we're creating a really important foundation for our partitioned object or objects. We're creating the partition function. And the partition function is like the algorithm for your particular implementation of table partitioning. When you create this partition function, you specify what data type the object will be partitioned on. You can choose only a single column for partitioning a given object. It could be a computed column, by the way, but in this case, we're choosing a date time to column. We're also setting up our partition function as range right in this case. You can select range left, and you might want to do that in certain circumstances. But with date time or date time to values, there's a recommendation to use range right, which uses the partition boundary points, which we define in this list here. I'm using variables, but you don't have to. The partition boundary points will now be lower boundary points since I have specified range right. If I were to specify range left, they would be upper boundary points, which can be awkward with date time values for a bunch of complicated reasons. If you want to dig into that more and understand it, check out our page on partitioning links. I have links to a lot of great resources that explain that in depth so you can really, truly understand that. But know that when you create a partition function, it's really important to know, is it range right or range left? What data types is it used for? So you may, if you have table partitioning already implemented, you may need to set up test scripts for your test environment that mimic your partition function in production, because you want to define it in the same ways that you've actually implemented partitioning so that you know if you create a sequence of changes on your test partitioning with just a few rows in dev, that it actually behaves the same way as your other. So we are using range right with a date time to value, and we're starting out with just a few boundary points here. Our partition function is named daily PF. Go ahead and get that created there. We can take a look at our partition function. Nothing has been done with it yet, but we're just going to take a look at it using the sys.partition function's built-in view. This isn't one I created. This one's built in. We can see the name, the fact that it is a range partition function, which is what you get in SQL Server. It does imply that there may be more types that come to us eventually. The fan out, which is how many, what is the total fan out based on the number of boundary points that I provided? Because I could provide, one boundary point or many boundary points. I could provide a whole lot. And the fact that this one was defined with range right. So you can easily check all of these properties about any partition function that already exists in your SQL Server. Next up, let's set up our database so that it has file groups that can be used with our partition function. Again, you don't have to do this. You could create partitioned objects and create them all on a single file group, either the primary file group or another file group that you've created. But in our case, we're going to do what many people do and create individual file groups for different partitions in our partitioned objects. So first up, I just add 6 different file groups to my database. The number of file groups that you need is the number of boundary points that you have defined in your partition function plus 1. So I'm adding 6 file groups. And next I'm going to add files to those file groups. I'm doing this with some dynamic SQL so that it automatically figures out based on, some information about where your current databases are, where it can put these file groups. So you don't have to use this automated code. It's decided this is designed so that you don't have to go in and change all the paths to be wherever you happened to install SQL Server. So again, only suitable for test instances. It does go ahead and the script just goes ahead and prints out, this is what it did. It added files on my system and on the S drive and MS SQL data, and it named them given things. So it added files to those file groups for me. How do I get my partition function to understand my file groups? In order to do that, I create what's called a partition scheme, or as I sometimes say, a partition scream when I misspeak it. The partition scheme takes the physical parts of your database and maps them to the algorithm of your partition function and its boundary points. So my partition scheme is named daily PS, and it is partitioning for this partition function. It is taking the partition function and applying it to this list of file groups. And the order that these are specified in is going to line up with the boundary points I provided there. Let's go ahead and create our partition scheme, or scream, depending on how you prefer it. And let's go ahead and take a look at one of those helper views I created to see how this is mapped out. This is one of the reasons I like those helper views, is I want to know, okay, I created this, but did it work like I thought it would work? We can see from our helper view that we're only looking at one partition function right now, daily PF, and it's mapped using this partition scheme to these individual file groups. It is a boundary on write, and I can see which boundary points are associated with which file group and how many rows are in it. Right now, I have 0 rows in all of my individual file groups. I haven't put any objects on my file group yet, so that totally makes sense. I don't really have anything on there, but I have this all laid out in my database. Next up, let's go ahead and partition an object. So right now I have this whole sort of substructure for my partitioning, but no objects on it yet. I'm going to go ahead and create a partitioned heap, a table without a clustered index, and that is probably not what you are going to want to do most of the time. I'm only doing it just to show you that you can and that you might do it by accident. You could absolutely go ahead and create this table with a clustered index before you put any data in it, but we're not going to do it in exactly that order today. We're going to do it in a different order. You can choose which order that you go ahead and do. So I'm creating a table named orders daily, and I am placing it on my partition scheme. And when I do that, I tell it which column I will be partitioning by. In this case, I am partitioning by the order date column, which is a date time 2, which matches what I defined in my partition function. So I create the object on the partition scheme, specifying the partitioning column that matches the partition function. Clear as mud, right? Here we go. We have created our table, and that created successfully. So how does that look? One thing we can look at, one thing that we often ask before we ever load any data is, okay, I created all of this up, and if I'm going to go ahead and put data in it, where would the data go? Would it do what I think it's going to do? You can actually check that before you insert any data, which is really cool. There is a partition built-in function that you can use, and you can provide it different data on, okay, if I added this value for my column that is my partitioning key, where would it put that? And it'll go ahead and tell you. So the values that I specify, some of them would go in partition number 1, some in partition 2, and then these 2 would go in partition 6. So if you're ever looking at, okay, I created this, I'm going to do this, where would it go? This is one of those cool little things that you can do to figure out what SQL Server would do without actually changing anything. So that being said, we're going to go ahead and insert some rows into our partitioned table. We're going to put 1,000 rows in one partition, 2,000 in another, 3,000 in another, and 4,000 in a final partition. And this is just so that we can easily compare, okay, I know I intended to put 1,000 rows in one partition. Is that what I ended up with, right? So different days relative to today are getting different data in them. Let's go ahead and load those up. These use our tally table that we created earlier to populate simply a number of rows without having to do anything like a loop on them. So, okay, we've loaded up our data. What does this look like? We still haven't put a clustered index on this guy. It's still one of those funky heaps in SQL Server, but the data does go into everything. You'll notice that indeed, if you look just first at the row count column here, sure enough, my 1,000 rows went into one partition, 2,000 in the next, 3,000. This all looks like it went where I intended, but you'll notice that I left 2 empty partitions at each end. Partition number 1 has 0 rows, and partition number 6 has 0 rows. Partition number 1 is associated with daily file group 1, just like you would think, and partition number 6 is associated with daily file group 6, just like you would think. Why did I leave these partitions empty? I did this on purpose to create what I like to call a partition sandwich, where the values that are in your partition range are surrounded by empty partitions. This is actually best practice in table partitioning, and it helps you when you manipulate your partitions and switch them around, which we're going to cover later. It helps you make sure that you don't get unexpected results where data sneakily moves in ways that you didn't predict. So in production, you probably actually want a different partition sandwich. You might want to create a lot of future partitions on the end of the partition table where you're going to be switching things in a lot, not necessarily just one. One is pretty much the minimum. So we're going to maintain these empty partitions at each end of our partition range, and I encourage you to always do that with at minimum one empty one at the end of each range. Our data did go into our table just like we thought it would though. So let's go ahead and add some indexes on our partitioned table. First up, I'm going to get rid of the weirdo partitioned heap. Even though I've already added data, it's not too late. I can still cluster my table, and I can add a clustered primary key to the table, and that works. And I'm also going to go ahead and add what's called an aligned non-clustered index. Notice that I didn't do anything special with this syntax for creating the non-clustered index. It just says create the non-clustered index on orders daily on the order ID column. I didn't specify anything about partitioning in here. That is something that you can choose to do. You could specify to create it on the partition scheme. But if you don't say anything, it will just assume that you want this non-clustered index to be partitioned. So SQL Server says, you didn't say, so I'm gonna just assume, give you the benefit of the doubt that you want this to be a partitioned non-clustered index. So that should be what we get there. I'm gonna create another non-clustered index though, and on this one I'm specifying on the primary file group. Right? I'm not saying to put it on my partition scheme. I'm saying put it on my primary file group. So this is going to be what's called a non-aligned non-clustered index in SQL Server. It's a non-clustered index that is on the primary file group and is not partitioned, and that index refers to a table that is partitioned on a partition scheme. So this non-clustered index is bucking the trend and saying, no, I don't want to be partitioned. Right? So I've got that one. Let's take a look at these and let's see how we could know information about them. First, I'm just going to show you the ye old SP help index view of these. So the built-in SP help index procedure in SQL Server shows us these guys, right? So here's our orders daily, and it does tell us, by the way, it says clustered unique primary key located on daily PS, which is the name of our partition scheme. But if we weren't super familiar with this, and if our partition scheme had been named something, like Fred, we might not know if that was actually a partition scheme or if it was just a file group, right? So depending, the naming of things does matter. And I do think you guys should name your partition schemes so it's clear what they are, so that anyone who happens to do this would know, oh, that looks like it's partitioned, right? Because it's not telling me a whole lot else about it. My two non-clustered indexes, one of them, the partitioned one, does tell me that it is, on the partition scheme as well. And my non-clustered one tells me that it's on primary. But again, if I had different names for these, I wouldn't necessarily know what was going on from looking. And I don't know exactly how many partitions these have or how they're laid out or anything like that. Let's take a look at our other helper view and look at specifically the orders daily object. How is that object laid out? This tells me a whole lot of information, and getting used to looking at this can take you a little bit. So I'll walk you through it. The first thing it tells me is I have a lot of different partitions and a lot of different rows. For this table, let me scroll down a bit here so you can see, this is for the orders daily table. I have index ID 1, which is my clustered index. It has 6 different partitions, and the index is named PK orders daily. And I can see that that's all mapped, to the daily PS partition scheme, which is sitting on those file groups. I can see that I have index ID 2, which is a non-clustered index named NC order ID orders daily. It's also mapped to the partition scheme and is across all those file groups. And just like the clustered index, it has empty partitions at each end and data in the middle in our partition sandwich. Finally, I have index ID number 3, which is our non-aligned non-clustered index. It only has one partition because every object, actually every table or index actually has a minimum of 1 partitions in SQL Server. So it is on the primary file group. It is not partitioned, which means it has 1 partition, and it has all of the rows in that one single partition there. It has this. It has the same data as everybody else. It's just got it in 1 partition there. So that's how we can see exactly how data is laid out in our object and with what ranges they are, right? Because we have 1,000 rows for the 23rd, 2,000 for the 24th, and so on. That's one of the things that's often very, very useful to see is how many rows for what partition do I actually have in this database? Very, very useful to be able to see. So that's how we can take a look at creating partitioned objects in SQL Server and having the insight to see what's in each partitioned object.